Please, good afternoon, everyone. In this today's session, we'll take another question from regression modeling. This question is find the least square regression line for the following set of data points. So the data point set is given as such: minus 1, 0. Second data point is 0, 2. Third data point is 1, 4. Fourth data point is the 2, 5. If we divide this data point as a x and y, this data point will be represented as x1. This value will be represented as y1. This value will be represented as x2. This value will be represented as y2, and so on. So you can see that here we have x1 as a minus 1, x2 as a 0, x3 as a 1, x4 as a 2. And we have y1 as a 0, y2 as a 2, y3 as a 4, and y4 as a. So this is the information that is given to us. There is a set of x and y values. Now you have to plot the given point and the regression line in the same rectangular system of axes. So we have to find the regression line for this given data point, as well as we'll plot the equation. So we'll use the Python Jupyter notebook to plot the equation. Let me go back to next slide. So first we cleared the table from the given data point. So as you note that earlier data point was minus 1, 0, 0, 2, 1, 4, 2, 5. From that we have extracted x1 as a minus 1, 0 as a y1, x2 as a 0, y2 as a 2, x3 as a 1, and y3 as a 4, x2 as a 2, and y3 as a 5. Now we'll take a summation of all the x values. So summation of x will be 2 minus 1 plus 0 plus 1 plus 2 is equal to 2. We again take summation of y, all the values. So that will be 0, 2, 0 plus 2 plus 4 plus 5. That will be equal to 11. Then we take x into y. So here we'll take x1 and multiply it with y1. So when we multiply minus 1 to 0, it will become 0. When we multiply the 0 to the 2, it will become again 0. When we multiply 1 to 4, it will become 4. And when we multiply 2 into 5, it will become 10. Again, we take summation of x multiply y, all the values. So it will be 0 plus 0 plus 4 plus 10 is equal to 14. Next value we'll calculate is the x square. So x square will be square of x. So when we take a minus 1 square, it will become 1. If we take 0 square, this becomes 0. We take 1 square, again it will become 1. And we take 2 square, it will become 4. So when we take summation of all the values of sigma x square, it will become 1, 0, 1 plus 0 plus 1 plus 4 is equal to 6. Now we'll proceed further. So now we have to calculate A and B. So as per the equation, A will be calculated as and into multiply by sigma x and y, x into y minus sigma x into sigma y. The whole value will be divided by a denominator that will be calculated as such, and times sigma x square minus sigma x whole square. When you put all the values from the previous table, you will get a value of a, that is a 1.7, and value of b, that is 1.9. Here b is the slope and a is the intercept. Now we can find the equation. To solve this problem as a Python program, we take x and y values as a numpy array. So earlier the x value was minus 1, 0, 1, and 2. and y value is 0, 2, 4, and 5. Now we'll take an numpy array of x and y, and then we print these values. We'll get a array value of x, all the values of x, and all the values of y. Now we need to solve the problem using the linear regression. So we'll uh, call the linear regression model and pass the value of x and y. So our model will be adopted to these values. Now our model contains all the required value that is desired for linear regression. Now we'll calculate the coefficient. So to calculate the intercept, we take the value model dot intercept underscore. To calculate the value of slope, we take the value model dot coefficient coef underscore. This will return the intercept and slope. So you can predict any value if you have an intercept and the coefficient. Now the whole equation will be y product equal to model dot intercept underscore plus model dot coef underscore into x. When we put all the values, this will be our regression line y equal to 1.9 plus 1.7 x, and when we predict the response corresponding to the y, this response will be as such, that is 0.2, 1.9, and 1. Yes. So the value will be 0.2, 1.9, 3.6, and 5.3. Now, in the next slide, we'll create a plot all these data as well as the regression line. So we call the matplotlib, and using the matplotlib, we plot the value of x and y. So you can see here that, yes, so you can see here that x, y values are this one, x1, y1, x2, y2, x3, y3, and x4, y4. And this is our regression model. So this regression line will is the best fit to these points. Now we'll go to the Jupyter notebook and we'll see how this program will run. Jupyter notebook is visible to everyone. Guys, Jupyter notebook is visible. Okay. Oh, no. So, so earlier we have solved this question. Now we'll go back to this question. That was, yeah, this was the question. Okay. So our example to have this question, let me copy back the question from the PPT so it will be more clear. One moment. So our example 2 is find the least square regression line for the following set of points. So these are the set points -1, 0, 0, 2, 1, 4, and 2, 5. Now, here -1, 0, 1, and 2 will be treated as the x values. So we'll create a x array, num array, and we'll pass these values. Again, 0, 2, 4, and 5 will be treated as a y set of values. So we'll pass this value to the numpy array. So we'll pass 0, 2, 4, and 5. When we create the numpy array, let me run this program. Okay, uh, run all above. Let me run all the cell above. Okay, now when we'll execute this program, you can find that the value of x and the value of y will be printed, and we pass this value to the linear regression model. We'll get a model that is fit on these values. Now we calculate the coefficient. So to calculate the intercept, as we have discussed, we'll call the value of model dot intercept underscore. To calculate the slope, we call the value of model dot cof underscore. And to calculate the equation, linear regression line, we put this value that will be y predict equal to model dot intercept underscore plus model dot coefficient underscore into x. So this is your regression line. To display this line, I have taken some slight modification in the print function so that you can view how this line will look like. And to predict any response, you can use this line. Just fill the value of f and you will get a value of prediction y. Let me run this program. Okay, now your intercept is a 1.9, your slope is 1.7, and the equation is equal to y equal to 1.9 plus 1.7 into x. And if you can see the PPT, the value of a and b, so you can find the value is same. So you can see that it is a 1.7 and 1.9. Same value is here. So it is again intercept 1.9 and 1.7. Now you can calculate the predicted response for any values. So let me run this predicted response. Let me comment it. All these points commented. Now, let me any value of x equal to earlier. Let me see what was the data -1, 0, 1, 2. So if I will pass the value of x equal to 3 and we want to see what will be the prediction, so it will be a 7 point something. So it will be the value of corresponding to x, the value predicted response will be 3. If I will pass it 1, I will get a response of 3.6. If I will pass it 4, I will get a response of 8.7. So you have developed a regression model which can be fit on those data points, as well as based on the input, it can predict the output for any given number. Okay, so let me make it more clear. These are your x values and this is your y values. Okay, so when I will predict the value for the x and y value, we'll get the information. One more. So these are the x values and this is your y values. So when I will put these values, you can see for corresponding -1, it is giving 0.2. For 0, it is giving 1.9 and 3. No, sorry, for y, it is giving 0 for 0.2. For 2, it is giving value 1.9. For 4, it is giving 3.6, and for 5 is giving 5.3. So these are the differences. This is your observed value, and this is your predicted value. So what is, you can see that there is a slightly difference between the observed value and the predicted value. Okay, now we'll plot this whole diagram. So first we plot our x and y point. So when I will plot the x and y point, you can see these are the x and y points, which will be represented by x and y axes. So this is x values and this is representing the y values. Now we'll plot our regression line on this data point. So now you can see this is your regression line, which have you can see there is a difference between the observed value and the predicted value. There is a difference between the observed value and the predicted value. There is a difference between the observed value and the predicted value. And same here, and there is a difference between the observed value and the predicted value. But it is a best fit regression line. So you can see that you can get a corresponding values to the F and so on. Okay, now we'll go back to our next example. Okay, so this is our next example. So please have uh, uh, these values. So we have a values of y and their corresponding value of y are shown in the table. So this will be x. So we have the value of x and corresponding value of y are shown in the table. So these are the x value. These are the y values. Again, we have to find the least square regression line y equal to ax plus b, and we have to estimate the value of y when x equal to 10. So this is a question. Please take your time and solve this question, and please let me know what will be the regression line, what will be the coefficient, and if you can, please write this program as in your Python Jupyter notebook, or you can use the Google Colab to do the program. Meanwhile, this session will be available for another 20 minutes for discussion and questions answered. You should solve this question, and then we'll discuss what will be the answer of this question. Thank you.